Hello there, this is Miss Nakayama, and today's lesson is 3.4a, Exponential Equations. So it is just one half of section 3.4, and we're concentrating on just exponential equations. And what you need to remember, the two objectives we're going to work with, is one, where the easiest way to solve exponential equations is if we can rewrite them with the same base, and if not, then we have to use logs to solve them. So let's go see what we have. First off, I hope it makes sense to you to see this right here. It says if b to the m equals b to the n, then m equals n. If I have two expressions that are equal to each other and the bases are the same, then the exponents have to be the same. So to solve these exponential equations, okay, the easiest way, as I said, to do it is to express each side as a power of the same base. That's why I've been giving you those activities in your daily check-in to practice knowing what numbers are powers of the bases. So when you solve, you first off write it with the same base, then you set the exponents equal to each other and solve for any variable that you might have. So this is the first example. Solve, I have 5 to the 3x minus 6 equals 125. So you look at the smaller base, which is 5, then look at the bigger one. Can I write the bigger one as a power of the smaller one? Well, if you've been doing your daily check-ins, then you know that 125 is equal to 5 to the third power. So now my bases are the same, and I can ignore them and set my exponents equal to each other. And now I solve for the variable. So I'm going to add 6, and then I'm going to divide by 3. You can always check by putting 3 into your original equation. Put it into this expression, see if you get 125. All right, now that's pretty straight up because 125 is a power of 5. When you look at this one, it again is going to be easier if you know I can't write 8 as a power of 4, but 8 and 4 are both powers of the same number. Okay, so what I'm going to be doing is I got to think about what base they are both powers of, and that is a base of 2. And 8 is 2 to the third, and 4 is 2 squared. And if you don't put parentheses in some way, if you don't put it around the exponent or put it around the base as I did, then you're going to forget that you have to distribute, and that's going to be 3 times x plus 2. So on the left side, I'm going to have 2 raised to the 3x plus 6, and on the right, we have 2 to the 2x minus 6. And now my bases are the same. I can get rid of them and set my exponents equal to each other, add an x, subtract a 6, and I find out that x is negative 12. Again, you can easily check it in your calculator. If you put negative 12 in this and negative 12 here in your calculator and simplify it, you're going to get the same numbers. So you know you have the right answer. Okay, so that was solving with being able to rewrite it in the same base. But I'm sure you understand we can't always do that. So how do we solve it if I cannot write it in the same base? And the first thing to do is to isolate the exponential expression. Then you're going to take the common log of both sides of each equation if you have a base of 10. So we're using common log if the base is 10, but you're going to take the natural log for any base other than 10. Okay, and you will see as we go through that. Then you're going to simplify using one of the following properties. Okay, this again, right here, is the composing of inverse functions that I talked a lot about in the previous. Both of these, composing inverse functions. And so you get the exponent for the answer. That's the easiest way to do it. Okay, and of course, then we finish by solving for the variable. So let's look at the examples of what we're going to do. The first one, solve 5 to the x equals 134. Again, the first thing you should think of, y'all, is can I write 134 as a power of 5? Well, it's not a power of 5 if it doesn't end in 5, so I cannot. And since I cannot write it in the common base, then I'm going to take the log of both sides. Now, Do I want to take the log log or the natural log, ln? If it's not, excuse me, if it's not a base of 10, then you want to use the common log. You want to use the natural log. So I'm going to take the ln of both sides. And when I take the ln of 5 to the x, that's that first property right here. That's this one. And the reason we do that is because taking the log allows us to move this exponent in front. And now I have moved the variable out of the exponent and I can solve the problem. So when I rewrite it, that's going to be x equals, x times the ln of 5 equals ln of 134. And I'm telling you, y'all, if you don't write this little step here, a lot of people forget to put this ln here. Totally changes the problem. But I hope you can see from here, I'm just going to divide by the ln of 5. So x equals ln of 134 over ln of 5. And then if you put that in your calculator, make sure you know how to do that. That is 3.14 approximately. Now, in MyLab Math, you have to give this answer. This is called the exact answer. You do not calculate anything, and this is calculated out, and you got to pay attention to how many decimals it says to round it. Okay, so you want to write this on your paper if you want some partial credit and don't get it correct. Okay, but this is also a good time for you to practice with your own calculator of knowing how to put this in, make sure that you can get things correct. Okay, look at this guy. 10 to the x equals 8,000. So again, I cannot write 8,000 as a power of 10 because the powers of 10 are 1 with zeros after it, but it is a base of 10. My exponential expression has a base of 10, so instead of using ln, I'm going to use log on both sides. So you need to recognize composing. The log is base 10. So log base 10, the log of 10 to the x is equal to just x. And then you have the log of 8,000. That's the exact answer. Put it in your calculator and find out it's approximately 3.90. So again, I'm putting them both in there because you have to answer both of them when you do your assignments and on the lesson check. Okay, example 4. Solve 3 to the 2x minus 1 equal to 7 to the x plus 1. I'm checking. Can I write 7 as a power of 3 or with the same base? And I cannot. And neither one is base 10, so I'm going to take the ln of both sides. So when I take the ln of both sides, then on the left side, I get to move the exponent down. So that gives me 2x ln of 3, 2x minus 1 times ln of 3 equals x plus 1 ln of 7. And a lot of y'all will write it like this, and if you do, y'all, you're going to miss the problem because you need to put parentheses around both of these because it changes the answer, and then the answer is not correct. That's the main reason. But it's an expression. ln of 3 is a number, just like we just saw up here. I mean, that's log of 8,000 is some kind of a non-ending decimal. It's just a lot easier to write it as ln of 3. So what I have to do is I actually have to distribute this. So I'm going to have to multiply it by that, and I'm going to have to distribute it over here. But I don't want to pick up my calculator, so I'm going to write 2x ln of 3 minus ln of 3, because 2x times ln of 3 and 2x times negative 1. And then I'm going to have x ln 7 plus ln 7. And this is probably one of the more challenging problems because people get stuck or don't really, actually it's not at this point. They know that they need to get any expression that has an x in it on the same side of the equation. So that means I'm going to move this guy over here and I'm going to move that guy over there. So that gives me 2x ln 3 minus x ln 7 and then ln 7 plus ln 3. Okay, so this step gets hard because at this point you've got to factor this out. So when you factor it out, it looks like that. And what do I have left? I have 2 ln 3 minus ln 7. This side did not change. But I now am trying to solve for x, and that's multiplication. So my x is going to be this is going to end up being divided, y'all. That's the divide because it's multiplied on the side of the x, so I'm going to have to divide it to move to the other side. So it will be on the bottom of my expression. And again, that's how you're going to have to put it in MyLab Math. So you got to know how to get to this point. And then you got to know how to put it in your calculator. So now is a good time to practice. Pause the video, put it in your calculator, and see if you didn't get 12.11. Okay? One more example and then a word problem. So we have e to the 4x minus 4e to the 2x plus 3 equals 0. So this, y'all, you're looking at it, might be a little scared by the whole thing, but really what you're looking at is just these exponents to start off with. And if you look at those exponents and you see that the one in the middle times 2 gives you the first one. If you see that, then that means that this is what we call quadratic-like or of quadratic form, however you wish to think of it. Okay? And so one popular way that is used in math is something called U substitution. I think y'all did this a little bit last year when you talked about trig. And what we do is we let u equal e to the 2x, which is that one in the middle. And then if I square both sides, u squared equals e to the 2x squared, and I simplify the right side, then u squared equals e to the 4x. Well, that's the first term. So when I rewrite this original problem with a u, it looks u squared minus 4 times u plus 3 equals 0. Well, then it's factoring. And the factoring of these problems, y'all, is pretty straight up. Okay? It's not going to be anything extremely challenging. You're looking for two numbers that multiply to give you 3 and add to give you 4. So I've got u minus 3, u minus 1, set each factor equal to 0, solve for u. But you don't stop there because if you notice, this original problem does not have a u in it. It has an x, so I got to solve for x, and I got to go plug this back in. So I plug it back in, and that's going to give me e to the 2x equals 3, and e to the 2x equals 1. Okay, now I'm back to what we were doing in this section, and that is solving exponential equations. And how do I get rid of that variable? I can't write them with the same base, so I'm going to take the ln of both sides. So ln of both sides of each of these. And then you want to notice these two are inverses of each other. So that means I have 2x equals ln of 3. These two are inverses. That's why we use ln when we have all the other times, except when we have a common log, because you'll forget this otherwise. And this is going to say 2x equals 0, because I'm sure you remember from an earlier lesson that ln of 1 is 0. That's an easy one to carry forward. Solve for x by dividing by 2. That's the exact value that you have to plug in or into MyLab Math, and divide by 2, and you get that. And of course, the decimal numbers are 0.5493 and 0. So those are our answers. And again, you can plug them back in to check. Okay, last problem, a word problem. How long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest rate, compounded quarterly? Okay, compounded quarterly tells me what formula I need to use. Again, if you write this down every time you do a problem, all right, try to remember it. So that is A equals P times the quantity of 1 plus R over N to the NT. Okay, so where is my, what am I looking for? How long? Okay, so if it's asking me how long, then that means it's looking for T. So I've got to know what all the other numbers, what's A? A is the amount I end up with. How long will it take 1,000 to grow to? So this is my A, 3,600. P is what I started with. R is my interest rate, but remember, you've got to write it as a decimal. And N is the number of times it happens each year. So N equals 4. So I plug that in. 3,600 equals 1,000 times the quantity of 1 plus 0.08 over 4 raised to the 4t. Now, I don't know if anybody told you, but when you got these many zeros, you got to get rid of them. But an easier way is to know that I can just cross out the same number of zeros on both sides. So I'm going to divide both sides by 10 and get that 3.6 equals 1.02 to the 4t. I did that because that comes out nice and even on your calculator. Again, I'm trying to get the variable out of the exponent. So how do I undo that? Undo an exponential with the log. So I'm going to take the ln of both sides, and that moves my 4t, my exponent, down in front. So ln of 3.6 equals 4t, ln of 1.02, and then I've got to divide. This is all multiplication right here, y'all. So if it's all multiplication, I can divide by everything in one fell swoop and say that t is equal to ln of 3.6 over 4 ln of 1.02. Plug that in your calculator and you get 16.2 years. And that is all we have to solving exponential equations. You undo exponents by the inverse operation, and the inverse of exponents is logarithms. That's how we undo. They undo each other, like addition and subtraction, like multiplication and division, like square and square root. Exponents and logs undo each other when we solve an equations. Thank you so much for watching, and y'all have a great day.